So product rule. As a reminder, if y equals f times g, right, y prime, I like to use this loop. I teach this loop thing for product rule, quotient rule, chain rule, okay? But as soon as you can let it go, good. As soon as you can do it without thinking of this loop, great. So we get fg prime plus gf prime, right? Yes? Everybody okay here? Good, so let's just do a problem here. Let's say y equals x sine x, right? So clearly a product, yes, you agree? Yeah? Good, first function, so we want to find y prime, right? So first function is x, derivative is what? 1, good. Second function in the product is sine of x, derivative is cos of x, yeah. We want this loop, right? So our first product in the solution is x cos x, right? So y prime is x cos x plus what? Sine x, yes? Jack, thanks. Agreed? Am I done? Pen. Ah, shoot. My pen might stop working now. Damn it. Yes, am I done? Yes. What's the only thing I would say I'd have to do if I could is factor. Right? I want one fraction at the end completely factored. I can't factor anything here, so this is it. I'm done. Hello? We okay? Good. The book's going to ask you for a second derivative. The book will ask you for a second derivative. In Calc 1, we go up to second derivative. In Calc 2, we go up to the sixth derivative. Each derivative tells us something about the function. The first derivative tells us is the function increasing or decreasing. The second derivative tells us about concavity. That's concave down. If it's right, if the curve is arcing like this, it's concave down. The second derivative will be negative. If it's arcing like this, that's concave up. The second derivative will be positive. Right now, you just are going to pretend that you have some new function and you want to find the derivative of it. That's all you're going to think about for second derivative. So, but watch how I do this second derivative. I'll say y double prime is x cos of x prime plus sine of x prime. I got to get the derivative of each piece of my original function. Why am I waiting to do the x cos x derivative? Because I have to use what rule? Product rule. Okay, but I know the derivative of sine, don't I? Don't I know the derivative of sine already? Say yes. Good. It's cosine. So notice now I'm doing my second derivative. Right? I got my first derivative. Who cares? Just pretend it's some new function. And I want to get the derivative of it. So of course it's going to be the second derivative. I know I got to do a product rule here, so I'm waiting. But this will be easy. So I'm waiting on the product rule, and I know cos of x so far. Now I'm ready to do product rule again. What's the first function? X. What's the derivative? 1. What's the second function? Cos of x. What's the derivative? Minus sine of x. So what do I get when I do my product rule here, right? So y double prime is what? Minus x sine x plus cos x plus the original cosec, right? Plus that one. So these things are going to get messy. I'm going to have product rules and quotient rules inside of product rules and quotient rules. So everybody with me? Notice I'm putting the prime symbol on and saying, hey, I'm about to take that derivative. Not ready yet, but I'm about to do it. Well, that one was easy, so I did it, right? So it's still there. But this one is a product rule. Here is my move. Here is the solution from it, right? So I've got my whole derivative here, and now I'm just trying to make it look as pretty as I can. Yes, Elizabeth? The arrow means go with this product, so minus x sine x, plus this product. Okay. So what's my final answer here for second derivative? 2 cos x minus x sine x. Again, if I can factor, I want to factor. We okay? Let's do a Jack question. Did you send me? You sent me one, right? Yeah. A question about this though? Okay. Nice. It's the one from the homework, right? Okay. Yes. Gotcha. Let me do one more product rule and then I'll do yours, okay? So let's do a tangent line. So let's say f of x is equal x squared e to the x. And let's find a tangent line at 1. So what do I need to get a tangent line? I need a y value. I need a derivative, and I need a slope. So y value is easy. It's just f of 1, right? So that's 1 squared times e to the 1. So that's just e. I need a derivative, but that means product rule. Do you see it? Product rule here? Yes? So my first function in my product is x squared. I often won't even put the variable there. I'll just say x squared is my first, 2x is my derivative, right? E to the x is my second product, second factor in the product, and the derivative is e to the x. So what do I get for f prime of x? I get x squared e to the x plus 2x e to the x. I look in the book and I see it's different, and I realize, oh, they factored, right? So I want to factor this if I can. Looks like I take out an x e to the x, and I get left with what, x plus 2? Either one is fine to find the slope, but I'm trying to get you used to getting the derivative that's factored. So one derivative is factored. Single fraction, completely factored numerator, completely factored denominator. When does this thing equal 0? What x value does this equal 0? Sure. Say again. Yes. The reason is we're going to be finding critical values, and when the things are factored, it's easier to find critical values. Critical values are when the derivative equals 0, meaning the numerator equals 0, or the derivative is undefined, meaning the denominator equals 0. So we're always looking for factors, and it's really easy to see that if x is 0, I get 0, or if x is minus 2, I get 0. Why is that important? Let's look at the graph of this thing. It was x squared e to the x, right? Look at what happens at -2. You see I hit the top of a hill? See I hit the top of a hill on -2? So what are my skis there? What slope are my skis there? At -2, what's the slope of my skis on that hill? Right there on the top of the hill, what's my slope of my skis? What's the slope of a horizontal line? 0. Is that what you're saying? Sorry, I'm old. What's the slope at 0? What's the slope there? What are my skis there? 0. So the derivative is telling me where I have horizontal tangent. It's telling me where I'm going to have the top of the hill or the bottom of the valley. Okay, we got our derivative. What else do we need for our tangent line? The slope. So m is going to be f prime at 1. So that's 1 times e to the 1 times 1 plus 2, so 3e. The slope is 3e. How are we doing here? Are we okay? Tangent line, y minus the y, which was e, equals the slope, 3e, times x minus 1. So I get y minus e equals 3ex minus 3e, or y equals 3ex minus 2e. Let's double check it with Desmos. So I had the point 1 comma e, and I have the tangent line y equals 3ex minus 2e. There it is. How are we doing? You have to have the mask on. I think it's only one more week. It'll be off. How are we doing here with the prodigal? Can somebody make some kind of sound for me? You okay? Nod something? Yes, question. Yes. If I have a particle, right? If I have a quotient, we're going to do that today. Okay? Matthew, mask, please. Thanks. Sorry. Okay. Let me answer the question from Jack here. This is from the homework that's due Monday. Sorry, Nathaniel, you okay? You set? Thanks. This is from 2.5, I think, right? Yeah, 2.5 number, I think it's 41. And we're doing a limit as x goes to infinity of square root of x squared plus ax. Remember, a is just a number, like 3, minus the square root of x squared plus bx. And again, b is just a number, like 7, right? So this is the limit as x goes to infinity of star. And star, I asked you all to use the conjugate to get my replacement function, right? So I'm doing square root of x squared plus ax minus square root of x squared plus bx times the conjugate over itself. Jack, you started there? Yeah. So upstairs, and this is where I think you probably had the issue, upstairs I get x squared plus ax, right? Because when I square the two like radicals, the radical goes away, right? And then minus x squared plus bx, and it's the parenthesis that I'm mostly worried about there. You got to make sure that negative gets distributed all over the conjugate. Am I right, Jack? That's where the issue is? Nope. So what happens here? What goes away? What can you see? The x squareds go away. So I just get upstairs, I get ax minus bx over that conjugate. And now I'm ready to divide by what power of x? X to the first, sorry. So I'm noticing an x to the first here. I'm noticing an x to the first here. I'm noticing a square root of x to the second there, but that's x. So the highest power of x is x to the first power. So I'm multiplying this by 1. No, not yeah, that's right. X to the first power. So what happens here? What do I get upstairs? I get a minus b, right? And then downstairs, I'm going to get x squared over x squared in the radical plus ax over x squared. And then the same thing in the second radical, right? So working this way is no problem, correct? So I'm just asking you to reverse engineer it. Square root of x squared is x. Let's go the other way. When you take an x and put it back in the radical, you got to up the power. You got to double the power. And then that's almost done there, right? You okay there now?
Yeah, I had a minute. I wasn't seeing that like the
Oh yeah, my little instructions. Divide by the highest power of x.
Yeah.
Yep.
So I just divided by 1 and then I get.
I gotcha. Yeah. Yep. Good. I want to look at the homework problem that's due in section 3.2. I didn't finish it because you all have to do it for me, but it's pretty clear that what happens here and here, I get 1, and then when I take the limit, what happens to these two pieces? They go to 0, right? I have an a over x plus a b over x, right? Those both go to 0. And of course the answer is in the book, right? So the final limit turns out to be a minus b over 2. So, but there's a step or two missing here, right? You got to finish that replacement function. You got to go back to your limit notation, take your limit, give me the answer. Cool. Let's look at this one problem. It's in 3.2. Anybody know what the first problem is I assigned in 3.2? Yeah, it was 29? Yeah, I think it's 29. Anyway, it's f of x equals square root of x e to the x. And so let's take a look at that. Okay, first of all. We looked at this one last class, but there's definitely something interesting happening at 0, right? We talked about it last class, right? It's a face plant, right? My face down in the snow. If I'm skiing down this hill, I'm screaming, by the way, right? I'm skiing down this hill, and when I finally get down to 0, I'm face planted in the snow here, and my feet are up. So that's a vertical tangent line, right? We already talked about the horizontal tangent line. Jack, you okay?
Yeah.
So let's go derivative here. First function is square root of x. What's the derivative? Yell it. Good. Second function is e to the x. What's the derivative? We're doing this loop with a plus for f prime of x. And I get square root of x, e to the x, plus e to the x over 2 square roots of x. It's important for you to realize sometimes this is the version you want to use, but you know I want a single fraction. But the book is asking you for a second derivative. So what I'm saying to you is use this version to get your second derivative. So if you do your second derivative, what rule are you going to use here? Triangle. What rule are you going to use here? Quotient rule. So it's easier to get our second derivative with this version. But of course, what's the final version I want? Right? What's the final version I want? If you're just giving me the first derivative, I need to get an LCD of 2 rad x. So I'm going to multiply this by 2 rad x over 2 rad x. Sorry, that's a rad x there. Right? So now I have a downstairs of 2 rad x, and upstairs I have e to the x plus 2x e to the x. Still not quite where I want it, because I can do what upstairs? Factor. When is the numerator equal to 0? Yes, sir. Negative 1/2, but that's not my domain. Remember, my domain is the domain of square root of x. So there is no horizontal tangent. There's nowhere where the numerator will equal 0 in the domain. When does my denominator equal 0? And at x equals 0. So there's going to be a vertical tangent at x equals 0. When my derivative is 0, I'll have a horizontal tangent. When my derivative is undefined, I'll have a vertical tangent. If the numerator is 0, I have a horizontal tangent. If the denominator is 0, I have a vertical tangent. No, yeah, so look, if I said my upstairs function is e to the x times 1 plus 2x, what do I have to do? What rule? Product rule. So I'm doing the product rule inside of a quotient rule. Messy. I would tell you, try it, but you'll see it's very messy. So while this is my derivative, I want to say is my final answer, when I'm going to do my second derivative, it's easier to use this unfactored one in this case. Question, Jack? That's okay. Good. I like it. I like it. Did everyone get solutions to the quiz? Anybody come in late and not get solutions to the quiz? No one else got it? I'm sorry. Did I said right? Correct me, please. Okay, we're ready. Quotient rule. Reminder. Quotient rule reminder. I have y equals f divided by g, right? So I'm looking for a fraction when I'm doing quotient rule, right? And I want to think of f prime, g prime, the loop with a negative, and then g squared over g squared. So y prime is g f prime minus f g prime all over g squared. This is our quotient rule. We want this on our formula sheet. because I'm going to give you a quotient on the test to do by a limit. And then I'm going to ask you to verify that you have the right answer using a quotient rule. I'll do one like that Monday or Wednesday for sure. Maybe today. All right, you ready for the first example? Our first example for quotient rule. We're ready? Almost. Nathaniel, Jack, well, 1 minute, sorry. Here we go. My function is e to the x over square root of x. Looks familiar. Domain is everything, all positive numbers, right? I can't use 0 here. I can't use negatives, right? We okay with that? So my upstairs function is e to the x. What's the derivative? E to the x. I owe you a proof of that. I will very soon. Downstairs function is square root of x. Hopefully we have this one memorized. 1 over 2 square roots of x is the derivative. And then we want to think of the downstairs squared, which of course is just x. Right? Okay, so we're ready for y prime. Y prime is square root of x e to the x minus e to the x over 2 square roots of x, all divided by x. Everybody with me? Yeah, everybody here? I'm going to clear. This looks familiar to what some of our first limits, right? We're going to clear fractions here with an LCD. Yes? Clear fractions with an LCD. So I'm going to clear with 2 rad x over itself. So it looks like I get 2 rad x times rad x e to the x minus 2 rad x times e to the x over 2 rad x. And then downstairs, 2x rad x. Nice, because some things cancel here, right? Everybody okay? So what do I get? I get 2x e to the x minus e to the x. And then I like keeping it as x rad x, but the book will often write x to the 3/2. Not done yet because I still can factor, right? So what do I get? I get e to the x times 2x minus 1 over 2x to the 3/2. There's my derivative. I'm asking for completely factored because it's easy to find these critical values. When is this 0 at 1/2? When is this 0 at x is 0? So I'm expecting to see a horizontal tangent at 1/2 and a vertical tangent at 0. When the derivative is 0, I get horizontal tangents. That's when the numerator is 0. When the derivative is undefined, I get vertical tangents. That's when the denominator is 0. Like this is chapter 4 stuff, but I want you to be ready for chapter 4 when we get there. So we're trying to always, I'll show you the problem I'm going to give you that you're going to be able to verify with the quotient. I'll show you 4 or 5. Listen. Yeah, so this is x to the first times x to the 1/2. When you're multiplying like bases, you add exponents. So 1 plus 1/2 is 3/2. I like this one better, but the book will use that one. All right, let's look at this function, right? Let's look at this function on Desmos. I need that e to the x divided by the square root of x. Remember what I said? Tangent line, you see the tangent line at 1/2? I'm at the bottom of a hill there, where I'm skiing. I'm at the bottom of a valley, so the skis are slope 0. And I'm on a snowmobile climbing up this hill, screaming when I go, and then eventually the slope of the skis will be infinite at 0. Let's do a silly one. Okay, we'll do a one that I don't remember how he's doing with the product rule, without the product rule. This one is with and without the product rule on a dumb question, because f of x equals 1 over x is really x to the minus 1. Yeah. Say it again. Yeah, square. Where are you? Yeah. Yeah, but that's the same thing as 2 times x to the 3/2. Yeah, for me, yes. But when you go to the book, you're going to see x to the 3/2, so you better know what they did, right? All right. What's this derivative without the quotient rule? Bring down the power, subtract 1 from the power, right? So it's negative 1 times x to the negative 2. So it's negative 1 over x squared. Hopefully we have this one memorized, but let's do it now with the quotient rule. What's my upstairs function? What's the upstairs? What's the numerator? 1. What's the derivative of 1? 0. Good. Downstairs is x. What's the derivative of x? Good. Downstairs squared is x squared, and we're using this loop with a negative. So f prime of x is 0 times x minus 1 times 1 all over x squared, which of course is just the same as we got with our shortcut. Yep. Right? Question, Elizabeth. So the reason is the proof. Okay? The reason is the proof. So you saw me doing the product proof. And I came up with that way of adding 0. If you do quotient rule proof the same way, right? And you could go out to the web and find how to add 0 on the quotient rule proof, but you'll see it doing that. So there's no way for me to say to you this is the reason, but I say to you I'll show you the proof. Okay? And so I've asked the computer science students to prove this, right? I proved the product rule last time. I said computer science major, math major, aerospace, you should do the proof. For aerospace, right? You're gonna do all the math Einstein did. You're gonna do a lot of math, and a lot of it is theoretical math, which means proofs. So the computer scientists should prove it. Elizabeth, what's your major? There you go. You prove it. You can see. Go out and say, prove the calculus 1, proof of the quotient. But try and start it until you get stuck, and then go look at that. Okay. And you, I guess you would kind of see, like if I started that proof, right? Y equals f of x over g of x. You're going to kind of see when you start the proof that you'll get the g squared, right? Because f prime, or better yet, y prime, is the limit as h goes to 0. Petra, you okay? Okay. Of f of x plus h over g. Petra, you okay? That's okay. So you can kind of see, you can kind of see, you can kind of see you're going to get, could possibly have two factors of g in the LCD. See that? You're going to have, in an LCD, you're going to have this times this, right? So you can kind of see a g squared there. Especially when h goes to 0, g of x plus h becomes g of x again. Right? So you can really see a g squared. Yeah. Always over the denominator. Always over g squared. All right, let's do another one. Let's do a tangent line. Wait a minute. Sorry, let's do a tangent line with this function. So f of x equals 2x over x squared plus 1. And let's do a tangent line at x is negative 2. So what do I need for a tangent line? A y value. How do I get a y value? Plug it into the original function, right? So I want f of negative 2. So I get 2 times negative 2 over negative 2 all squared plus 1. So it looks like what, negative 4/5? I need a derivative. So let's get our derivative here. Is this okay? Let's get our derivative using a quotient rule. Upstairs function is 2x. What's the derivative? 2. Oops. Downstairs function is x squared plus 1. What's the derivative? 2x, good. I need the quotient loop with the negative and dividing by the downstairs squared. Don't factor it out. Don't FOIL it out. Just leave it as it is right now, okay? So what's our y prime? 2 times x squared plus 1 minus 4x squared all over x squared plus 1 quantity squared. Make sure you're with me there. Make sure you're with me there. And go ahead and simplify that numerator for me. Let me know when you get there. Remember, I want everything completely factored, right? So I want to leave things factored. So I want to leave it factored. Factor, right? When is this factor 0? And x is 1. When is this factor 0? And x is minus 1. When is this factor 0? Never. So I'm going to see two places where I have horizontal tangents. I'm going to see no place where I have a vertical tangent. When my numerator is 0, I'll have horizontal tangents. When the denominator is 0, I'll have vertical tangents. Look at the graph. It's called a serpentine. Maybe we'll see why. Look, 2x over x squared plus 1. Serpentine. You ever go down, ever been in San Francisco? There's a hill. It's so steep that they made the road like this. They call it Snake Alley. Serpentine. Look, at minus 1, what are my skis at right here when I'm skiing? 0. Horizontal tangent. At positive 1, my skis are horizontal, slope is 0. That's when my numerator was 0. Is there any place where my skis are vertical? No. That's why the denominator is never 0. All right, we had what point? -2 comma, -2 comma, -4/5, is that right? Nice. We need our slope at -2. Somebody help me. Right, so I get y prime at -2. So I get 2 times 1 plus 2 times 1 minus 2 all over -2 squared plus 1 quantity squared. -6/25. Verify for me, please. We get the same thing, Chrissy, yeah? Nice. Boy? Yep. Elizabeth, I'm sorry, Abigail, you okay? Abigail? You okay? You need food? Okay, tangent line. Y minus 4/5, y minus a -4/5, right? Equals -6/25 times x plus 2. We all in agreement there? Yes? So y plus 4/5 equals -6/25 x minus 12/25. I know I'm going fast, but this is, you know what to do here. This is 25th, sorry. You're not copying me, you're just doing the tangent line yourself. Uh-oh, made a mistake. Oh. Wait a minute, I screwed up here. What? Yeah, why we got negative 4/5, right? Yep. I just screwed up my B value, that's all. It's minus 32/25. That's what I get for going so fast. Yay. How are we doing? Anybody get there? Christy, yes? Yeah, yeah. You too? Thanks. Yes, a little bit. Yes, like y prime is the derivative. That's the slope at any single x value. Yeah, to the original function. Exactly. And then you use your equation of a line. Guess what? Have a great weekend. Oh. Practice, 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 practice.